Okay, moving onward and upwards, you knew it was going to get more complicated. You should be able to recognize that this first R creates a circle. Your professors will expect you to know that off the top of your head. And this second R creates a dimpled lemmason. Now, this may be difficult for you to remember. You may not remember it from last year. I did put notes on yesterday's notes indicating what's what. Hopefully you'll be able to recognize them when you graph them on your graphing calculator, but most calc professors expect people to go through calc without any kind of calculator. Now I want you to look carefully here, and I want you to notice that on this page I have put a screenshot of the graphs, and I have shown their point of intersection. Now there is a problem there, and that problem is quite simply that point of intersection is in terms of x and y. That creates a lot of problems for people who are heavily reliant on their calculators. So we're going to talk about how to solve for this using the tools that we learned in, Algebra 1. Okay, up to this particular point, these are Algebra 1 skills. However, they are no longer as of this point, and we need to figure out what theta would be to make the sine of theta 1/2. With very little effort, we can find our values of theta that makes sine of theta equal 1/2, and now we need to figure out what our R value is. And we have found our theta values and our R values, and we're going to go ahead and label the graph. Once we've labeled the graph, we're going to set up our integral. And just like it always has been, you take your upper curve minus your lower curve, and you find the difference between the two. And all we need to do is set that up. So I'm just going to replace the larger R, and the larger R is the one that's on top. So in this case, it is the circle. And then I'm going to subtract the smaller curve, which is the lemmason. And there we go. We have it totally set up. I am so sorry. I did not make a mistake on this slide, but in the past, people have made a lot of mistakes on this one because everybody wants to find the shared area of the two curves. That is not what you're looking for. You are looking for the area that is in the circle but not in the lemmason. So we're looking for this area right here. And I'm sorry that I didn't think to mention that until just now. So, I'm just having fun coloring. Okay. And this next one is going to be the area shared by them. Okay, so on this next one, we're trying to find the area of the little part that is shared by both the circle and the cardioid. And in order to do that, we need to find their points of intersection. So, very simply, we are able to find our points of intersection. Now we need to find the area between the two curves. Now, to make this problem a little bit easier, it is easier to think to change the values there of -3/2 2 pi over 3 into positive 3/2, negative pi over 3. Therefore, you have one swoop. You won't have to section it off into multiple pieces. So in order, if you are confused right here, which a lot of people are very confused during polar in calculus, if you're confused right here, I want you to graph these 2 points on a piece of polar graph paper, even if it's online. It doesn't really matter, because I'm sure that you're going to run out and buy polar graph paper just for one problem. Anyway, that is why I was able to make that transition to what looked like brand spanking new coordinates, but it's actually just the same point. Okay, so what we have here is the area that is shared by both the cardioid and the circle from pi over 3 to pi. So we're talking about the arc, I don't know if you can see this purple pen on this black, from here to there. We're talking about that slice of pizza. Now, we still need to worry about that little shaded part right there. And in order to address that, we need to use our circle from 0 to pi over 3. So that right there estimates the area of the brightly shaded piece. Now, what I did not do was set this up in any way that is familiar to you. I set this up in a way that is intuitive instead. But we need to add those 2 areas, and that will give us the total area of the section, of the common interior of the cardioid and the circle. And that is all for today. And I hope you are finding this useful. If you do not, you can Zoom with me anytime this summer. If you get stuck on any of the homework, I want to make sure that you are prepared for Calc 3.